Hello everyone, Krishna this side. So in this video, I'll be covering this LeetCode problem 2411. Smallest subarrays with maximum bitwise OR. You can pause the screen and read the problem statement. I'll directly explain on the screen. These are the examples that have been given to us. In input, we notice that we are given an array and it is expecting an array as an answer, right? So these are the constraints and it is really necessary to go through the constraint at every point in time whenever we are trying to solve any questions. This gives us clarity like what it is trying to expect, the time complexity that it is trying to expect. Okay, so here the n basically length of this array, it is going all the way to 10 to the power of 5. So it is clear that we have to write this code in n log n or en. We cannot write this code in n square time complexity. That is the clarity that we can get it. Okay, so considering all these things, let us now focus on the screen and we will see like what it is trying to say and what we have to achieve. So we have given an array for each index I in this array. Okay, so these are the index like 0, 1, 2, 3, 4. For each index I in array, find the smallest subarray starting from that particular index I. Okay, whose bitwise or is the maximum possible value. Okay, so we have to figure out the smallest subarray starting from this particular index I. When we start from this particular index, the subarrays could be this one, this one, this one, this one, or entire array can be a subarray. When we start from this particular index, subarray can be this one, this one, this one, this one. Okay, these are the possible subarrays that we can get it. So we have to figure out the smallest subarray starting from that particular index whose bitwise OR is the maximum possible value. Okay, so when we perform the OR operation between all the elements that are available in the subarray, whatever the answer that we are getting it should be the maximum, and the array length should be minimum as possible. Okay, the idea is clear. Now we have to return an array of same length. Okay, so whatever the answer that it is expecting, we have to return an array of answer, okay, of same length. Obviously it is the same length, where answer of I, whatever the index I, basically if it is 0, so answer of 0 is the length of the smallest subarray starting from that particular 0th index that achieves this maximum bitwise OR. Okay, the goal is clear, so we have to just figure out the maximum bitwise OR, and if that maximum bitwise OR, if we are getting it with the smallest subarray as well, so we have to consider that length, and that length is something what we have to keep on updating into this particular answers array. Okay, I hope the question is clear. Now let us start with the first index. When I is basically 0. Okay, when we start from the first index, we have to keep on generating all the possible subarrays. Okay, let me write down all the possible subarrays from this 0th index. Okay, starting from the 0th index, these are the possible subarrays that we can get it. The single element can be a possible answer, these two elements can be answer, these three elements can be answer, these four, or all the way last element. When we go, these all the possible subarrays can be an answer. Okay, so out of this maximum, whatever the maximum subarray that is giving us the maximum bitwise OR value, so this subarray should be having smallest length. Okay, that is something what we have to figure out. Okay, so for the first, the OR value is basically 1. When we perform OR operation between this single element, the value is going to be the same one. When we perform OR operation between 1 and 2, the 1 is basically represented in this way in binary formation, 2 is basically represented in this way. When we perform OR operation, 3 is the answer that we are getting it. So 3 is something what I have updated. When we perform OR operation between 1 to 15, here the answer is going to be 15, because 15 represent in this way, and 1 is basically this way, 2 is basically this way. So at any point in time, whenever we are performing OR operation, if there is only single set bit is also available, the answer is going to be set. When we perform OR operation between 0 and 1, 1 is the answer that we get it. 1 or 0, the answer is again 1. 1 and 1, the answer is 1. So only in a case where all the bits are 0, if all the bits are not set, that time only the 0 is value. That's something what we are going to get it with the OR value. Okay, I hope this idea is clear to you all the guys. Now when you perform OR operation, here also 15 is the maximum answer that we can achieve, here also 15 is the maximum answer that we can get it. Okay, so out of all this, maximum answer that we are achieving is 15. Okay, we are getting it in 3 different cases. So obviously whichever is the smallest subarray length, that is something what we have to consider and we have to print into the answer. So 3 is the answer that we are printing because it is having length 3. So for this index 0, starting from the 0th index, having length 3, with this subarray 1 to 15, we are getting the maximum possible bitwise OR value. Okay, that's how it basically says. When we now focus on the I equals to 1, that is like the first index. Okay, so these are the possible subarrays that we can get in starting from this first index when I is basically goes to 1. So for 2, the answer is 2. For 2 and 15, the answer is again 15. For 2, 15, 1, the answer is 15. Here also the answer is 15. Okay. So it is clear that 15 is the maximum answer that we are getting it. So having length 2, we are getting the best answer. Right. So why to go further and get largest length, right? The goal is like we have to get the smallest subarray. Okay. So smallest subarray is having length 2. So 2 is something what I will be updating at index 1. Okay. I hope this is clear. Now going ahead, like for 15, okay, these are the possible subarrays: 15, 15, 1, 15, 1, 8. Right? So for 15, 15 is the answer. For 15, 1, 15 is again the answer. 15, 1, 8, 15 is the answer. Okay, because see how 15 represented 1, 1, 1, 1. Okay, that's how 15 get represented. 1 basically get represented in this way. 8 basically get represented in this way. When we perform our operation, whenever there is any single bit is also available, that is a set bit. So we will be considering it as 1. Here also it is 1, here also 1, 1. So this is like 15 is the answer that we are getting it. Okay, so yes, the best answer that we are getting it is with having length 1. Okay, single element can be giving us the best answer, right? So yes, here length is 1. Correct. Now for 1, when I is basically pointing at this particular index, I is equals to 3. 1 is the element that we have, or 1 and 8 is the element that we have. Okay, these are the possible subarrays starting from third index. So here the answer is 1. From here the answer is basically 9, because 8 is represented in this way, 1 is represented in this way. So when we perform this, this is basically 9. Okay, when we convert it into the decimal. So here the best answer that we are getting is 9. Okay, best answer that we are getting is 9. So we have to get the length. Length is basically 2. So 2 is something we have to update right over here. Correct. Now for last element, like I equals to 4, here only single element is available, so its length is basically 8. So at any point in time, whatever the last element is available, it is going to be 1 at any point in time. Okay, so that we don't have to worry a lot about that. Okay, that's how we have to generate the answers. I hope the question is pretty much clear now. So whatever the different sub arrays that we generated starting from the 0th index, and we will keep on generating the answers, so that way we can get the answer, but the complexity with that particular approach is going to be n square. Okay, we will simply try to generate all the different sub arrays starting from each index, and we will keep on collecting their OR values. So whichever the smallest sub array that is giving us the best answer, okay, we have to consider that, and we will just update their length in the answers array. But this way we will be having n square complexity, and that is not acceptable at all, because they expect complexity to be n or n log n. We cannot go further. Okay, so I hope this is clear what we discussed right over here. Now let us try to see how we can write the code in O of n. There are better approaches as well, like to write this code. Okay, now let me just clean these things. Okay, so yes, let us suppose this is the array that has been given to us. This is the array, and we just have to collect all the sub arrays, smallest sub arrays possible, starting from each index, which is giving us the best possible bitwise OR value, performing the OR operation between the all the sub arrays. Okay, I hope the question is pretty much clear. So what we will do is we'll create an latest set bit, okay, array having values from 0 to all the way 31. So there will be 31 index that we will be having starting from the 0th index. So in total, this latest set bit is going to be 32-bit array value. Okay, so why we are maintaining this means, like, if we carefully observe right over here, this nums of I is basically having value all the way to 10 to the power of 9. Correct. So it is having value 10 to the power of 9. So this is like we can hold all the integer values in this particular one. Correct. So any integer value is basically having range 2 to the power of 32 minus 1 to 2 to the power of 31 minus 1. So this is the range that we will be having. Correct. I guess this range is pretty much clear to you all, guys. So this is the range that we have, right? So what we have to do is, maximum element that we are having in this particular array is going to be 10 to the power of 9, which is obviously inside this particular range. So any value that is we are considering, we can have all the set bits possibly active as well. So because of that, I have created this latest set bit array, which tells me which bit is basically set at which particular index. Okay, you don't get it what I'm trying to say immediately, but yes, I have created this latest set bit array, which holds all the bits that are there, and that particular bit when it got set, from which particular index it got set. Okay, that is the information it basically holds, and we'll get this like why we are doing this and all. So from starting from the last index, we will keep on looping in this particular array. Why we are starting from the last index is like if we start from the first index, there is a chance that we have to go through all the different possibilities that are there. Okay, we cannot skip any particular possibility and we have to check which particular subarray is giving us the best answer. Okay, so we cannot skip this particular case. But when we start from the back, we can pre-compute the answers. Like there could be a chance that like we can, when we are starting from the back, because this last element going to be this single element that is there, it is obvious. For this one, we might have processed some operation on this last index and we collected some answers, so that like with the help of that we can easily figure out if single element can be giving us the answers, or we have to consider these two elements to get the answer for this particular one. Okay, so that is the clarity that we can get it. So we will start from the back. And what we have to do is, the idea is, see, whatever the elements that we are considering, let us suppose 8 is there. So 8 is basically represented this way, like 1 0 0 0. That is how it basically gets represented in the binary formation, correct? So here the last bit that is there is basically third. Okay, here it is 0 1 2 3. The third bit is basically set. Okay, it is basically set means like the value is basically 1. Okay, so third bit is basically set. So at any point in time, when I consider this element, its set bit is like, this is the set bit that is there. Okay, all the way like 31 bits we will be having. So only the 0th bit is basically set in this particular case. 0th bit is basically set, correct? That is the clarity that we are getting it. So with this particular one, we are getting 1 as an answer, but there is another value that is available which is having third bit as a set bit. Okay, previously there was an array element that is there in an array which we have processed backside, which is having third bit as a set bit. Okay, and we cannot set that particular bit with the help of this one. Okay, so what we can do is we can simply keep track of that particular elements index in this particular latest set bit array that we are creating. Okay, so basically we will keep on tracking like whatever the set bit that are there, with this help of this particular element, we will keep on updating into this latest set bit array. That way it gets us clarity that like previously this third bit that was there, like this third bit that was there, it got set from this fourth index, and that fourth index cannot be set with the help of this one. With the help of this particular one, we cannot set that fourth bit. It is clear that then this particular fourth bit, if we consider, okay, like sorry, the third bit that we are having, and we are trying to OR with this current one, we are obviously going to get the best answer. With this help of this single element one, we cannot get the best answer. Okay, because the third bit can be set with the help of other elements as well, previously which we have traversed. Okay, and that is something what the whole idea right over here. So we just keep on tracking like any bit that are there available, that are there, either those bits are getting set or not with the help of this current index. If so, we will keep on updating into the latest set bit array. Here we will keep on updating the index value. Just have to focus right over here, index value, so that this third bit got set with the help of last index. Okay, with the help of last index it got set, and that is something we cannot set with the help of this second last index. With the help of this one, we cannot set that bit. It is clear. So if it is not possible to set that particular bit with the help of this particular current index, it is obvious that when we merge both of these different values, when we perform the OR operation with this 8 and 1, we are going to get the best answer instead of this single one element. Okay, so that is the clarity that we can get it. So let me keep on updating this latest set bit, and we will keep on performing these operations until and unless we will keep on getting the generating the answers. Okay, okay, so what we will do is we will start from the back. We will keep on checking like what are the set bits that are available in this particular index element that is there. Okay, 8 is basically get represented in this way, right? So third bit is basically set. Okay, so third bit is set means like in this array right over here, the third bit that we will update with this current index. So index are like 0 1 2 3 4. So with the help of fourth index, we were able to set this third index. Okay, so that is the idea, like we are just updating this latest set bit with the these index values. Okay, how we can perform that operation? So when we get this 8 in this particular binary representation, we will simply traverse through this latest set bit array. Okay, and what we will do is traverse in the sense like we will start from the 0th index all the way to the 31 elements that we can have, right? Like those many elements only can be set bits. Okay, because the range is basically int, and int is having a set bit like from 0 all the way to 31. Okay, last 31 bit can be a set bit as well. Okay, so what we will do is we will simply perform an AND operation, and we will be doing this one left shift of this 0. It goes all the way to 31. Okay, what it basically says, one left shift of 0, that means like we are shifting this one 0 times. Okay, left side. So one is basically in this way, correct, all the way 0 0 0, and we are trying to shift it 0 times. So what it does, like 0 times, like it is going to be the same one, correct. So when this I started from 0 all the way it goes to 31, so this will keep on generating, like for 0 to 1 it is the answer. And when we perform AND operation with this particular 8, the value is basically equals to 0. If the value is basically equals to 0, we are not updating the latest set bit. We are trying to do, only if there is a set bit, then only we are updating this latest set bit with this current index that we are having. Okay, so when we perform this one left shift of, okay, one left shift of 3 times, when we shift this one, so it is like 1 0 0 0. Okay, when we perform this operation one left shift of 3, it is like 1 0 0. Okay, that's how the answer basically gets, because one got shifted 3 times. Okay, one got shifted 3 times. Okay, that's how it basically looks like. Whatever this left shift option, right shift option, I think that should be, you should have these clarities, then only you try to solve these questions. Otherwise it will be really difficult to try to understand this type of questions. Okay, and when we perform AND operation with this 1 0 0 0, the AND operation basically works at any point in time. There are 1 1, then only it generates the answer, right? So the bit is basically going to be the set 1. So here the answer is basically greater than 0 when you perform the AND operation, correct, that is going to be the 8. So at any point in time, if the answer is basically greater than 0, that means that particular bit is set. Okay, so third bit is basically set, so we will update with this current index that we are at. So 4 is something what we have updated right over there. Apart from that, no other bits can be set in this particular one. So that is something what we have done right over there. Let me clean this up. Okay, the moment we collect all the set bits that are available for this particular index, that is like only a single index that was there, like the third index, which was the set bit. So we updated it with this 4. Okay, we have updated with this 4 in this latest set bit, correct. So once that is done, we will be out of this first for loop starting from 0 to all the way 31. Okay, once that is done, we have to check like what is the current index there where we are at. So fourth is the current index where we are at. From this latest array, what is the maximum value that we are getting it? All the other values are basically filled with zeros. Okay, but only one index what filled with 4, and that is the maximum value that we can get it. So we will simply consider that, and plus 1, that is something what we have to do, that is because we are considering this current element. So this is giving us the 1. Okay, so it is clear that last index definitely going to give us the 1 as an answer. 1 as an answer, I'll maintain here the answer. Okay, 1 is the answer that we are getting. Okay, because from this one we can get for this last element that is there, it is getting filled. Like let us suppose if it is 15, so all these index like 0 1 2 3, all these values are basically filled with 1. All these values are basically filled with, sorry, this last index that is 4. Okay, out of all this maximum value is 4, that is the value that we can get it, and currently we are at the fourth index only. 4 plus 4 minus 4 plus 1, when we do it, that is the answer that we can get it easily. Okay, that is the first thing. So still if you didn't get it, like no worry, we will, when we go and start traversing backside, and when we try to fill this array, you will get the idea like what we are trying to do. So initially the 8 is the value that we have, and the third index is something what we have filled with the 4. That is the index from which we got this bit as a set bit. Now next is the I pointer is pointing at this particular one. So 1 is basically get represented in this way. When you perform AND operation with one left shift of starting from 0, starting from 0 all the way to the 31, it gives us that like the only the zeroth bit that is there, zeroth bit that is there, this one, it is basically set bit. So in the latest set bit, we will update with this current value, like that is the 3, the third index that is there, right? That is something what we will update right over here. Okay, so this way it gives us clarity that like with the help of third bit we are setting this one. Okay, this 0 value is basically got set. Okay, now once this is done, like once this for loop is done, like we are running I from all the way 0 to 31. Once this is done, we are out of this loop. So we check that what is the maximum value that we got it from this particular array. The maximum value is 4. Okay, the 4 is the maximum value. So it is clear that, see, even if right over here it is 1, even if right over here it is 1, here it is 8, here it is 8. Okay, the answer could have been like this. So here it could be 4, right? Because 0th bit got set with the help of this 1, and here it could be 3 because with the third index, this third bit got set. Okay, that is the clarity it basically uses. Okay, so it is clear that even with this particular setup, okay, it got set with third. The maximum value that we are getting is 4. Okay, maximum value that we are getting is 4 from this array. When we start traversing, maximum value we are getting is 4. So it is obvious that with the help of this 8, we cannot set this 0th bit. With the help of this 8, we cannot set this 0th bit. Okay, and 0th bit got set with previously whatever the array elements that are there, with computation of that, performing this particular operation, and operation and let shift operation, we got to know that there was an element which basically set this particular 0th index. Okay, and it is obvious that with the help of that and this particular current index, when we perform OR operation, we are going to get the best answer, right? So when we perform AND operation with the 8 is the answer that we get it. When we perform AND operation with 8 and 1, the answer basically we get is 9. Maximum answer is something what we have to figure out right over here. Okay. Maximum answer is something what we have to figure out right over here. So 9 is the maximum answer that we are getting it. So it is obvious that we have to consider both the elements. Okay, because this 0th index cannot be set with the help of this 8. Okay, so we have to make sure that whatever the previously which index basically set this 0th index, or any other maximum elements. Let's suppose going ahead, there were multiple array elements that are there, like again 2 was there. So 2 is basically like first bit is basically set with the help of this 2. So 5 is something what I have to update into this array, like this first set bit was basically helped with the help of 2, we can set it. So out of this maximum value is basically 5. So it is clear that with the help of 8, 1, 2, I can get the best answer, because when we perform OR operation between this 8, 1, 2, we are going to get the best answer, because this first bit that is there, we cannot set with the help of 8. First bit that is there, we cannot set it with the help of 1. Okay, that is the clarity that we can get it. So that's how we are maintaining this particular array elements. Okay, and we are keep on checking, like with the help of which maximum value that is available in this particular array. So currently maximum value is 4 in this particular array. So 4 minus currently third index is what we are having, minus 3 plus 1. When we do this, 2 is the answer that we are getting it. We will update right over here the answer. 4 minus 3 plus 1, 2 is the answer that we are getting it. 2 is what I have to update right over here. Okay, this way we will keep on updating this latest set bit that was there, whatever these bits that are there, 0, 1, 2, 3, these bits with the help of latest element that is there available with us. If we are getting the best answer, we will keep on updating this one. Okay, let me keep on shifting these bits, like previously what was there, that is something what I'll write to maintain those checks, and we will perform the operation. Let me clean this up. Okay. Now once we are done with one, like this was the array that previously we started with, so I just updated their states as well in this latest set bit. Now we are at this particular location. The I pointer keep on moving in the forward direction, like from back we are starting, right? So now um, the I pointer is pointing at this particular location. Okay, I is pointing at this location, so its value is 8. Again, we have to check like what are the set bits for this one. So 8 and, okay, 8 and 1 left shift of 0 to all the way 31, we will keep on doing it. So whatever the set bit that we are getting, that index is something what we will keep on updating. When we perform that operation, this index got updated with the 2. Okay, this particularly third index got updated with 2, because we have to keep track of latest set bit. I don't want to go in the past and keep on tracking, like we are actually looking for the smallest subarray, right? So if initial array element are basically giving us the set bits, why to go all the way to the last elements, right? So that is how we are keep on updating this latest set bit array. Okay, we are keep on updating this latest set bit array. Whatever the element that is there, what are the set bits that are available in this current element, we will keep on updating into this latest set bit, that index particularly. Okay, so that I don't have to go to till the last element and check, like with the help of this last element, whether this bit was set or not. If any new element that is coming, if it is basically setting that particular bit, we will update it with that index. Okay, because we are looking for the smallest subarray. Now once this is done, like we go all the way from 0 to 32, it is clear that from this array the maximum value that we can get is 3. Okay, maximum value that we can get, because with the help of third index, this 0th bit was getting set, and with the help of this 8 we cannot set that bit. It is obvious that then 8 or 1, when we do it, the answer is basically 9. Okay, that is the best answer that we can get it, right? Like with the help of single 8 we cannot get the answer, maximum answer. And it is clear that 8 or 1 or 8, it is also giving us the 9 as an answer. But we since updated this array with the 2, this third bit got set with this 2, so we are not going all the way to the last index. Okay, that is the clarity it basically gives us. So with the help of this, like this answer is basically again like maximum value that we got was from this array was 3 and current index is 2 minus 1 plus 1. When we do it, the answer is something what we will get it. So here the answer is basically 2. Okay, because considering 8 and 1, we are getting the best answer. Okay, once we are done with this, we are, the I pointer is basically pointing at this particular index. I pointer is pointing at this particular index. Okay, it is getting lag. Okay, let us quickly wrap this up. So I pointer is pointing at this particular index now. We collected so far the answers, best answers that we can get is smallest subarrays, and we are keep on updating this latest set bit array values as well. Now 9 is something what we have. 9 is basically get represented this way. Okay, and here we get to know that like 0th bit and the first bit are basically set. So 0th bit we will update with 1. Okay, and the third bit is also something what we have to update with 1. Okay, we are keep on running a another for loop, and we are keep on checking whether the bit can be set bit or not, and whatever the latest value that we are getting it, that is something what we will keep on updating. So third bit got set with 1. Okay, now when we traverse from this particular array, it is clear that the maximum value that we are getting is 1. Maximum value that we are getting is 1, and currently we are at the first index. So 1 minus 1 plus 1, when we do it, the answer is basically 1. So it is now gives us the clarity that 9 individual can be a best answer, because 9 is basically represented in this way. Okay, 9 8 9 comma 8, that is another subarray. This can be again when we perform the OR operation, this is also going to be the same one. 9 8 1, again with the help of this, like the answer is going to be the 9. And even if we consider the last element as well, 9 8 1 8, that is going to be the 9 only. So what we have done, we just keep on tracking like these bits that are there, right? With the help of this current 9, if it is getting set or not. So whatever the previously 0 and 3 that was there, like with the help of 8, we were able to set the third bit. With the help of 1, we were able to set the 0th bit. That those bit can be easily set with the help of 9, right? So when we perform OR operation between the any two elements, if both the elements are 1 1, it is obvious that whatever the value that is going to be there, it is going to be 1. It is not going to change, right? So we have to make sure that small sub array that we are considering, with the help of it, we are actually setting all the bits that we can set. Okay, so yes, that's how we can do it. We can solve this particular question. Okay, now with the help of 9, like 1 is the answer that we are getting, and the latest set bit got updated with 1. Okay, now the next idea is like the I pointer got shifted right over here to the first index. Okay, and simply the 1 is basically living in this way, and when we perform an AND operation with one left shift of 0 to all the way 31, it basically tells like the 0th bit is basically set with this 1, so it got updated with 0. When we check from this array, it is clear that like 1 is the maximum value that we are getting. So current index is 1. 1 minus 0 plus 1, when we do, the answer is basically 2. So it is obvious that 1 and 9 are the best answer that we can get it. Instead of considering all the elements in some array, subarray, 1 and 9 can be given with this particular smallest subarray also, we can get the best answer. Okay, that is the clarity that we get it. So answer is something what we have to update with these two. Okay, this is how we can generate the answers. I hope that you get the idea. If not, please make sure to solve as many questions as possible from this bit manipulation. That way only you will get this type of intuitions, because it is obvious that most of the questions with this bit manipulation, you just have to think of like how these bits can be get manipulated and all, and that way we have to generate the answers. Okay, so first thing is like I'll create an answer, array answer, like answer equals to new int, let us say that this length is something what we will get it, int n equals to nums dot length. Okay, here it is having n, and this answer is something what I'll return at the end, return answer. Okay, that is the first thing that I have done. And you guys remember that we are maintaining an array, latest set bit. Okay, let me just name it at here set bit, sorry, set bit new int 32 size will be having, it is having 32 size. I'll run a for loop for int I equals to last index n minus 1. From there we are starting, right? I equals to n minus 1. It is lagging, so I cannot see like what is happening right over here on the screen. So I minus minus, so starting from the last index we are running. So what I'll do is here I'll create a max index that we are getting it from this given set bit array. So initially I'll point it to this current I element that is there, I index that is there. So I'll run a for loop for int j equals to 0. J basically was Instead of j, let me name it as a bit, or else fine, j is something what we have, it goes all the way to the 31 plus plus. So here in this particular for loop, what we are doing is we are trying to see if this nums of I, and we are performing AND operation, and we are shifting this bit one left shift of this j. Okay, we are keep on checking like which particular bit is set in this particular nums of I. If this value, if it is actually greater than 0, okay, if it is actually greater than 0, okay, this means that bit is basically set in this nums of I. This particular jth bit is basically set. So what we will do in the set bit of this j, we will update it with this current index I. Okay, current index, whatever the current index I, that is something what we are keep on updating it. Else what we are doing, whatever this max IDX that we have, we will update this. If previously this particular bit, if it was set with any particular one, mat.max, we will get that value. So whatever the set bit of this current j is there, initially it got filled with all the values with 0. And if at any point in time, let us suppose if we are at some index and this value got set with previous index, by processing it, max index value is something what we can get it by this way. Okay, so now once this for loop is run, what we were doing in the answers of this I, we are updating it like this max index, whatever the maximum value that we got it, minus this I plus 1. Okay, that is the operation that we were doing it. So ultimately we have to return the answer. So let me try to see if it is working fine or not. Okay, it is getting accepted. Let me try to submit this code as well. Now with this, it is clear that like we are running this for loop only one times, like it is big O of n, and this inner for loop is like we are running all the way to 32 times every time. So total complexity is like 32 cross n, which is big O of n only. And obviously this space is required, that is something what we are returning. So big O of n is the space that we are using, and this is the constant space 32 of bit we are using it. Okay, this way we can easily solve this question. So if you get this idea like what we have done, please make sure to like this video. If not, please try to solve multiple questions from the bit manipulation. That's why only you will get this type of intuitions. Okay, thank you for watching this video. Bye bye.